Okay, welcome. This is one about vertical circular motion. We're trying a different recording method. This is an object going around in a vertical circle, same object top and bottom. The important thing to remember is that there are only two forces acting. So the only forces acting are gravity and reaction. So, having said that, we need to make sure that we understand how those things lock together, how they work. So, at the top, and we'll talk about circular motion, or the circular force in a minute, and what it actually means. So, at the top, net force to the centre equals N plus mg. So N plus mg equals mv squared on r. And the mv squared on r is what we call the centripetal force or circular force, and that is the resultant force. At the bottom, net force to the centre equals N minus mg. So N minus mg equals mv squared on r, or N equals mg plus mv squared on r, which is as we would expect at the bottom of a loop. You feel a little bit heavier, and that's not an unusual thing to be thinking. Okay, so one of the practical things we do frequently in this, I'll just get that focus readjusted, is when something goes through the bottom of a dip, and this is a really common thing to calculate. So let's do an example. 2 kilograms cart at 5 ms to minus 1, and the radius equals 1.0 meters. So at the bottom, we know that the reaction is going to be mg plus mv squared on r, so that's going to be 2 by 9.8 plus 9.8 by 5 squared over 1 squared. And we'll calculate that in class because I can't actually don't feel like calculating immediately. At the top, so opposite when we've got a hump. So same sort of thing. We've got a 2 kilogram cart. We're going at 5 meters per second. The radius equals 1.0 meters. And because it's at the top, N plus mg equals mv squared on r. So N equals mv squared on r minus mg. Which means that in theory you can get a negative answer, and we'll talk about what that means in a minute. Because obviously negative answer makes no sense at all. So equals 2 by 5 squared over 1. I think I put a 1 squared in the previous page, but it doesn't matter. We'll ignore that. Now, which means that you cannot actually get a negative number with any meaning. It means you've left the surface. So one other thing we should add, what you would actually call is more like a neutral speed, where n equals 0. If you had a neutral speed where n equals 0, you would have mv squared on r equals mg. And note again, as is commonly the case, the mass is irrelevant. So v equals the square root of rg. So the perfect speed to have 0 contact with the surface over a hump is v equals the square root of rg. I'm hoping this makes some sense for vertical motion, and we'll be doing a lot more of this in class.